Good morning, everyone. Thanks for joining us on the webinar on UDFBs this morning. Um, we'll go straight into the presentation as usual. If you have any questions, just feel free to put them in at any point and we'll get to them at the end.
Hello and welcome to today's webinar. Today we're going to be talking about the data-find UDFBs in Cscape. Let's get started. Let's look at our agenda for today. We'll introduce you to these new data-find user-defined function blocks and look at what they do, what they're useful for and how they work. We'll have demonstrations throughout and finish with a Q&A session. Firstly, as user-defined function blocks, there are a set of 4 new UDFBs that you can add to any variable-based advanced ladder application in Cscape and that are also available for download. They allow you to search for a specific value in an arrayed variable. So if you have a very large array, maybe with 1000 different elements in it, and there's a specific value that you're looking for somewhere in that array, these user-defined function blocks will return the exact position of the first instance of the value you're looking for, in terms of where it is in the array. They have a variety of different uses. This sort of data find is useful if you're looking for a specific character in a string of ASCII characters. For example, ASCII characters are most often represented as a byte array, and each character is a byte long. And you may have an application where you're looking to extract an important piece of data from a string of ASCII characters that may be coming in from a barcode reader, let's say a carriage return character. And it's important for you to know where that carriage return is located in the string as you extract the piece of information you're looking for from that barcode. This data find function would allow you to search for a carriage return in that byte array and tell you that location. Another use might be for those of you who utilize data logging or other type functions in Cscape, where you're recording the test results in your machine. If you're recording temperatures or pressures and there's a specific pressure value that you know you're looking for, but you don't know exactly where that pressure test result occurred, so you could search for that value. And this function block would come back and show you specifically which test it was where that was the result you received. Another application might be if you have a parts database and that parts database may contain part numbers and part details that you need for a particular machine function. But maybe that part database was built with the parts being added in as created order rather than sequential order. Finding a particular part number in that part database along with the other data associated with that part can be difficult. However, with a function like this data find, you can search for the unknown part number, it'll come back with the index, where it is in the database, and then all the other parameters associated with that part can be easily found because they have the same index. To be able to use these data find UDFBs along with any other UDFB, you firstly need to import them into your project. In Cscape, you can go to the Project Navigator section, and in the Logic area, you can right-click and press Import Logic Module. When you select Import Logic Module, you'll be able to navigate to the folder created that contains those UDFB files. They're actually CPU files. That's the part number extension. And then you can add the ones you're going to use one by one to your project. Once they're imported, they will show up in the project toolbox under the UDFB section, where you can select and drag them into your logic editing area to add them to your project. We recommend with the UDFBs that we create that you connect them to the always-on contact that's connected to the power rail, so that they're always receiving power even when they're not enabled to perform their function. That way, they can perform whatever kind of initialization that they may need before they're called to action. Now we'll look at the specifics of the data-find UDFBs. Every user-defined function block has inputs and outputs, and that's true of the function blocks that are built into Cscape as well. So we'll look at those 4 inputs for the data-find UDFBs. Firstly, the enable input, which is labelled as EN, is used when it is turned on to start off the find operation. So turn on enable and leave it on until the function block is done with its job. The next input value is called target value, which is the numeric value that you're going to search for in your array, where the format will be either byte, integer, double integer, or real, depending on which of the 4 UDFBs you're using. There's one data find UDFB for each of those 4 data types. Next, there's the input array that you're going to be searching through to find the value, which again will either be a byte, integer, double integer, or real format. When you enter in the input array, you're going to type in the name of the variable array along with an index of 0. The 4th input is the last index input, which is strictly an integer value that represents the last index you want to search through. So for example, you have an array of 200 part numbers and you want to search through that array for that specific part number. So maybe the name of that array is part, and your input array would be input as part with an index of 0. And if that part array has a dimension of, let's say, 200, the last index would be entered as an integer of 199, because indexes with arrays are 0 based. Now we'll look at the outputs of the user-defined function block. Firstly, there's a Boolean output, which will turn on whenever the find operation is complete. Next, there's value index, so that's the index for the array for the value you're looking for. So if it turns out that the value you're looking for is in the very first location in the array, then that value index will come back with a 0. If it's in the 100th location in the array, it'll come back with a 99, because it's returning an index which is 0 based. Finally, the last output is an error output, which is a Boolean value. And the only real error that can occur is if you set your last index input to the UDFB to an improper value, which would be a negative value or greater than 999. Because the largest array search that we can do using this user-defined function block is 999, so an array of 1000 members. Now we'll look in more detail at a few of the example applications where those functions could be useful, starting with a parts database. So let's say you have a parts database and it consists of a series of arrays with part number and then different parameters for the part. So it could be a length array with height, weight, etc., and all the arrays use the same indexes. So for index number 52, that calls out the same part number and the data associated with that part number for length, width, height, weight, etc. However, let's say this part number database was created or is constructed by listing the parts in the order with the parts were created. Finding a specific part in that list could be challenging. But using this user-defined function block, it can become very easy. Using this data-find user-defined function block, if you know the part number you're looking for, that could be your target value, and you could search the entire array for that target value. Then, the function block would come back and say that the part number is located at index 36. So now you can find all the other information on the part that you need to operate your machine. Things like length, width, height, etc., because all those other arrays use the same indexes. So index of 36 will give you all the information you need for all those different part parameters. So that's one example where it can be useful. Another example would be dealing with ASCII strings, and often when you're dealing with ASCII strings, it may be because you have a string of data that's been provided by, for example, a barcode reader. So let's say we have an application where a barcode reader is being used to read the next part number that we need to process on our machine, a packing machine, for example. Now this part number is a numeric number and we'll say it's represented by 6 digits, but the location of the part number within the barcode string is not always in the same consistent location because some of the data fields are a very varying length, so the barcode length is not consistent, and where specifically you're going to find that part number may not always be in the same index location within that string. However, it may be a case where you have a consistent prefix and a consistent suffix that is bordering that part number there, which you can then use to extract the part number from the barcode. So using these data-find UDFBs is one way that you can identify where the prefix character and the suffix character are located. Now we'll look at the second example of finding a character within a string using Cscape. So we'll start by showing you where those imported UDFBs are in the project. So we imported all 4 into this project, and to do that, we right-clicked on Logic Module and selected Import Logic Module. Then navigated to the folder containing the CPU files, and then did a star.cpu to find all the CPU files available in that folder, and then we selected the ones we wanted to import. We can see that these 4 user-defined function blocks have not been locked, so if you're interested you can click on them individually and you can see how they were built, and they're well commented so you can see specifically how they were used. Now one other thing is that there is a PDF file that's included in the download package that gives you all the details on these 4 user-defined function blocks, their inputs, their outputs, and their detailed operation. So you don't have to backward engineer this code in order to tell exactly what they do and how they do it. So now we'll close this tab, and let's start to look at our application. So firstly, we'll look at this main logic routine that we called decode barcode. So here's the example we were describing. We're getting in a string of characters from a barcode reader, and within that string of characters somewhere is the part number string that we're looking for. It's not always in the same location, but it does have a constant prefix and suffix that can help us find it within the string. Before we look at this code, we'll see the setup at the bench. So here's the demo screen, and here we're describing the application. And up here in this area is where the barcode string is going to come in as the barcode is read. And down here is where we're decoding everything. So in our example, there's a number sign which identifies the prefix just before the part number string. And then there's a carriage return character that identifies the suffix immediately after the part number string. So when we execute our code, we're going to see the barcode here, and we'll press new to process the information. And then we'll see this data fill in here. We'll identify where the prefix is located using our user-defined function block. We'll do the same with our suffix. And then there's a small bit of extra code written to extract the part number string from the overall barcode string, and then at the end we'll convert that string into a double integer value, which is our part number. So we'll go back to Cscape and look at how we built this logic using our user-defined function blocks. Anytime a new barcode comes in, we're going to get an input that's going to turn on, and then we'll start finding the prefix, the £sign character, which happens to be ASCII 35 decimal in the overall string. So now we'll look at how we executed our user-defined function block. Firstly, it's always on and always getting power, even when it's not finding a character or finding a value. The enable input is our find prefix input. So this is an input that's going to come on and stay on for the entire time that we are processing our string and we're finding our index for the character we're looking for. The character or value we're looking for is decimal 35 because the sign is ASCII 35. So that's the value we're looking for in our byte array. The byte array that we're going to search through is barcode in, so that's the string array or byte array where all potential 64 characters coming in from the barcode are going to be. And then we're specifying the last index we want to search through as index 63. So we're going to search barcode in 0 through barcode in 63, looking for a value of 35. When this function block is complete, the done bit will turn on, and as long as there aren't any errors in our last index, this error will not turn on. And then the output of our function block is going to be the index for this prefix that we're looking for. And once we've successfully found our prefix character and the done bit is turned on, we can verify we have a good result because our prefix index will have a positive value. It won't be a negative value unless we couldn't find the sign anywhere in the string, then it would return a -1. But as long as our done bit turns on and our value of our index is 0 or greater, then we know we can move on and find our suffix. We'll find our suffix position in the same way as our prefix. We're searching the same range in the array, but this time we're looking for a carriage return, which is a decimal of 13. Once we're done, we'll verify that we've received our suffix, and then we're going to be ready to move just the section of the string that contains our part number into a separate string array. So to do that, we're going to calculate the index location within the string where our part number starts, and create a couple of indexes so that we can work our way through the strings character by character. We're going to copy starting index for our part number. Let's say it's the 15th character, and we'll say the part number index is a value of 14. So we're going to start with the index of 14 on our barcode string, and we're going to copy that into a separate string, which is a maximum length of 6 characters, because that's what we've specified in this application. Then we have a short loop here, which is copying character by character from our barcode over to our part number string. And then we have a simple conversion from ASCII to double integer, because remember, a 6-digit part number that's all numeric could be big enough where it needs a double integer value. Then when we're done with that, we'll clear out our buffers and our indexes and be ready for the next barcode. So that's what's going on in the logic. So here we're simulating 2 or 3 different barcodes, so let's look at the first one coming in. So here's the string that we read in from our barcode, and we know that what we're interested in is extracting the part number, and we know that the part number prefix is a sign and the suffix is the carriage return. Now the reason you see a box where the carriage return is located is because there is no character in the font that we're using for carriage return, so it just shows it as a box. So we want to use those new user-defined function blocks to extract effectively 123 from this string. So we'll enable logic by pressing the new button, and you can see everything worked. So our prefix was identified as 14, so the index for the sign is 14, and it's the 15th character because indexes are 0 based. The suffix is located at an index of 18, that's the carriage return. Our part numbers start one further on from the prefix that starts with the 1 there. When we extract that string by itself, it's a string of 123 ASCII, and when we convert it to a double integer, it has a value of 123, so everything works. Again, we utilise our new user-defined function block a couple of different times in our logic, so we'll clear that out manually and we'll look at the next string that comes in from the barcode reader. This time it looks a bit similar, but it's quite different. The part number is 5-digit long instead of 3, and it's located at a different part in the string. But the constant is it has the prefix and it has the suffix, so we can use our logic and the user-defined function block to find where the part number index begins and extract the part number first as a string and then as a double integer. Now we'll do it one more time, looking at a third string that contains our part number. This time again, we can execute our logic, and we can see that we get the part number we're looking for and all the other information we needed to get there. So that's our application example for today. So again, there are 4 data find user-defined function blocks, one for byte type arrays, one for integer type arrays, one for double integer, and one for real. You can import these user-defined function blocks in any Cscape variable-based advanced logic application, but you may have to use Service Pack 8 or later. These user-defined function blocks can be useful in a variety of different applications, including those involving ASCII string handling, which we demonstrated in some detail, along with some that might be used in a parts database. So that concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, so next week we have controlling a smart motor with an open. And we are away the following week at SPS in Parma. So just in case you're wondering about that webinar, we are taking a week off for that, and then we're back the 1st. I'm not seeing anything in at the moment, so thank you all for joining us this morning, and we hope to see you again next week. Have a good day.